let me introduce first speaker, Mariya. She is a dedicated front-end developer with a keen focus on creating seamless user experiences. After making a sharp career pivot in 2021, she has specialized in PHP, Laravel, and email campaigns. Mariya is also proficient in sweepstake promotions and has gained valuable experience in working for a Fortune 500 company. Her commitment to continuous learning and exploration fuels her ability to deliver exceptional results. And with a strong emphasis on understanding and enhancing end-user interactions, Mariya is a dynamic and valuable asset to any team or project she joins.
Thank you, Violina. And I'm going to introduce our second speaker today. Violina is a seasoned software developer with a focus on the mobile app development, dedicated to providing seamless cross-platform experience. Her journey in the tech industry began in consulting before the transitioning into programming. With expertise in React Native, TypeScript, Firebase, and Next.js, she excels in both web and mobile application development. Currently, Violina is part of the mobile app team at the largest video streaming platform for equestrian sport and breeding events, where she consistently strives for excellence. Excited, Violina.
Thank you for the introduction, Mariya. Now I will hand over to you.
Thank you so much. Okay, so I'm gonna share a screen. Please do confirm that you see my screen.
We do.
Okay, so we are in our third session of JavaScript, and we pass what is functions, variable. We talk about the ES5, we talk about ES6, and I'm gonna say that most likely it's probably already a bit of a confusion. So if we do start really cool and really excited, probably down the road, you start feeling very overwhelmed, and there is a little bit of cliff of confusion, and you are not sure, is that you're gonna be able to pass and have all the knowledge of JavaScript because it's so broad. So I have a little bit of graphic, which is gonna help you understanding that whatever you feel and whatever you're coming from, it's totally normal. And that is a reason you should move forward, not stop. You should move forward practicing. So efficiency, you can do learn with other people, do pair coding. This is super important. Find a buddy of the course. We are having 25 people in a Slack channel in a private group. You can tag anybody and ask them, hey, are you available today? We can chat about what is variable, what is var or let. Secondary, keep challenging yourself, not only watch the videos which we provided, because by watching, if you have hands-on theory, it's okay, but you're gonna have a hands-on practice and you're gonna understand that you doesn't know how to close this function. That's have to be avoided. Stay motivated. It's really easy to go down. It's very underestimated and it's totally understandable, but you should stay motivated. If you feel down, please do talk to anybody surrounding you. You're going to understand you are not alone. All going to all those stages, you're going to feel different emotions, but at some point, you're going to go back to normal. You're going to feel back to awesome, cool state. And this is going to be a ready statement for your job. That doesn't mean when you start looking for a job, you're not going to stop learning. It's continuously. And that's not just for JavaScript, that's for React, that's for any type of framework or anything you're learning on a development. Secondary, which I'm noticing a lot of people do, is they buy a lot of courses. So I can include myself as well in that type of a person. I'm buying a lot of courses. I start very exciting the course, the first 24 hours, 2 weeks, 3 weeks, I'm very excited. And the end of the day, I'm noticing that I don't finish them all. So please do stick to the course. Even though you're having a hard moment, you should keep continuing practicing on your own. This is not optional. Without practicing outside of the courses, you will go nowhere. This is not theory. You need to have a practice. Don't get stuck trying to write the perfect code. Okay, the code never is going to be perfect. You got to understand that it's coming with the practice, with the years, and just write tons of code, no matter of the quality, sync feedback, and embrace the fact that you never will know everything. So the session today is going to start it with the scope. This is crucial. for us. So what is scope? Scope is dedicated visibility in a lifetime of variable, determining when your code is particularly variable is valid and accessible. If you're not grasp upon a scope independently, because you can affect your code and basically create a lot of bugs. So scope is not a profoundly influencing the way you structure your code, manage your data, and prevent conflicts between the variables. As we know, we learn what is variable on the first section. So scope is, we're having a few types of scope. We're having a global scope, we're having a local scope, and we're having a block scope. I'm gonna walk you through the three types of scope. So global scope is when we are defining a variable outside and it's accessible from outside of the function, and it's accessible and visible for everyone. So block scope, unlikely global, and a local scope, which are defined in the functions. And the local scope is a private room with a building. It's an enclosed space where variables are only accessible from in a specific room. I'm gonna dive into the global scope. So imagine you having a billboard, you're on the street and you having a billboard. Everybody walking on the street are able to see the billboard, right? This is not hidden. It's not in a private room. It's not in your complex where you're living. So that's mean when we defining a variable outside and we define that it's a global, can be used from each function. Sounds really interesting, sounds really cool. The problem is that can create a lot of bugs. So in this example here, variable is declared in a global scope. We're having a var global variable. I'm in a global scope, and we have a function. And when we call the function, my function in console.log, we're going to be able to access the variable. I also have created a code pan. Just for a second, where I can show you. Okay, so this is my code pan. So currently we're having a let global variable. I'm a global variable and the function. And we're having a display function call, and we're having a second function, modify the global. So basically, if we do console.log, okay, we are going to be able to see on the console log, it's appear that the global variable, okay? We define on the top of the stack. Also, if we console.log after the modify global function, okay, we're gonna be able to access. So when you're having access to a variable from each function, that means the variable is global. Okay, so moving forward. Okay, moving forward, we're having potential issue which we are facing when we having a global scope of the variable. If you're working on a small app, say for example, a calculator, yeah, you can maybe not having that much of a bugs, but if you work on a broad project with a lot of developers and you assign the variable globally, that can predict a lot of bugs down on the road. So global scope be quite convenient, but it's have a lot of downsides. So you gotta make sure that you intentionally, when you're assigning the variable. Since global variables are accessible from anywhere, there are sustainable intended changes and conflicts. For instance, if multiple parts of your code modify the same global variable, it can be lead to unexpected behavior, right? Moreover, global variables can make your code less modular and organize it. If everything in the town square, it's become challenging to manage and isolate different aspects of your program. So yeah, this is a downside side of the global scope. So be very intentional when you are assigning a variable. Next one, we're gonna talk about best practice for using a global. So you go global scope, declare a variable on a global scope when generally need to access a bit globally. So you're making sure that that's not gonna change. Avoid overriding global variables. Use descriptive variable names. Choose variable name that clearly convey their purpose, especially in a global scope where they can affect many parts of your scope. Okay, so we kind of talk about the global scope, or we talk about the good parts, the bad parts. So we gotta understand that when you're assigning a variable, it's intentionally, it's gonna be on the global scope, and you don't wanna change it down the road because multiple functions probably gonna reuse it. The next one, we are gonna talk about a local scope. Local scope is a private room with a building and enclosed space with the variables. When you declare a variable in a local scope, it's limited and visible only for the block of code or a condition in which is defined. So it cannot be accessed in other functions. It will be defined and accessible just for the current function. Currently, we have a function. We declare the variable in inside of the function, a local variable. I'm local scope. And we can cancel that the local variable inside of the function. I'm having also a little bit of example, again on the code pen. So basically, we're having this function greet, and let's message we're defining, we are assigning the variable inside of the function locally. So if I, for example, call the message outside, I want to call the variable outside of the function, I should currently receive a message is not defined, and it's not defined, and it's throwing the error because the message is defined inside of the function. It's not accessible for outside. Okay, I hope this makes sense. It's really important and crucial to understand when you can call a variable. So currently, if I call console.log the variable inside, okay, it's printing out hello world. Because again, the variable was initialized inside of the function, so it's locally accessible. That's very briefly overview of the local scope, but give you an idea that you have access to the variable which are defining inside only of the function. I'm gonna go back to the slide. Okay. So variables declare in a local scope. Accessing local variables is very, very straightforward because they are inside. These variables are isolated from the outside world, ensuring that they don't accidentally clash with other variables in your program. Yeah, so this is a huge difference between the global and between local scope. Again, global scope is access has from everywhere, and a local scope is just inside of the function. So as we see on the example, you're not able to call the variable outside of the function. It's going to throw error. It's undefined. Benefits of using local scope. Okay, isolating can prevent implementing with variables and other parts of your code. Allows you to compile your code, making it more manageable. Variables in a local scope can be defined and used with specific function or block, promoting code reusability without affecting the rest of your program. Yes. Secondary, we're gonna move to the function scope. Function scope, it's when we JavaScript variables declare with var or a function scope. That means they are available through the entire function regardless of the block. Variable declare with letting const inside of the function also have a function scope, but they are limited to the block if they are declared on them, right? Block scope. Block scope was introduced in ES, I'm gonna say 6, when let and const was introduced. Block scope in JavaScript is like a series of nested boxes. Unlike global and a local scope, which are defined by functions, or global context block scope is created with a specific code. If, else, and switch. You also can see it a lot on the loop. Variables declared in the block scope are only accessible with the block in which they are defined. These are like hidden treasure inside of each nesting though no and accessible only with their respective compartments. I have a little bit again demo on the CodePen. Okay, so here we're having a loop, and for example, again, we declare a let's I inside. So let me open the console. Okay, so I actually console that work, so let me remove it. Okay, so again, if I try to access the outcome of the loop I outside, it should throw an error. It does because we are trying to access the result outside of the block. So we are not able to have access due to we defined it, the variable inside of our block. And block scope, it's like if, else, which statement, again, our loops. So I hope that makes sense. It's pretty straightforward. Again, I'm going to try to access the I inside of the blocks, and we should be able to see the result inside of loop 2. Yeah. Okay. So block scope. Second. Okay. So this is for block scope. They're very similar with the function scope. Block scope and a local scope confuse it often, but they're a key distinction. In a local scope, variable are typically defined within a function, while block scope is created with a block if, for, or while statement. So we're having here we're having a function, my function. If it's true, and we declare a variable inside, let block variable as well, and we console that block. So it is accessible. The local variable, it is accessible. The block variable is gonna come up as undefined. In this example, accessible with the function because it's in a local scope. How to use block scope with let and const. This keywords allows you to declare a variable and a block scope, making it easier to control variables, visibility, and a lifespan. In this code block, we're having example block scope. If it's true, let a block variable, I'm block scope it with a let. Const block var, I'm a block scope it with const. So we're gonna console that block, the both variables, and it's gonna be a come up as undefined. In this code, block variable and const block are block scoped and inaccessible outside of their respective blocks. Okay, block scope and conditional statement in the loops. Function check condition, we're having the let's result equal to before condition, and we're having if statement. If it's true, let's result inside of the condition. This is a block scoped variable. In this code, the variable result block scoped inside the if statement if it doesn't affect the result variable in outer scope. Understanding lexical scope. So this is another scope which we're going to talk about it. The scope chain in JavaScript fall in a particular known as a lexical or a starting scoping. Lexical scoping means that the scope of the function determined by where the function is declared, not where it's called. In this example, we are assigning a variable a, I'm a global, and we're having a function, force function. We're having again a variable inside of the function I am first function. We are calling second function. We're calling outside first function. In this example, we went through second function is called from in the first function. It still reference the variable from the scope where it was declared. Lexical scope, which is the first function. The concept is similar to how book pages are ordered and arranged in a specific sequence, with each page having access to the previous one. Yeah, so this is a lexical scope. Okay, yeah, so this is regarding the scope. Most importantly, you have to understanding that overview. We're having a global scope, we're having a local scope, and we're having a block scope. You have to be very, very careful when you are assigning a variables as a global scope, because that can introduce a lot of bugs. Please do use the course resources also outside if you're having any questions in terms that you want to do more testing, you want to do more challenges beside the homework which we are providing. Please feel free to share with us. There is a lot of code pens, there is a lot of materials out there where they can guide you through it. And I'm gonna hand it to Violina.
Thank you, Mariya. Hopefully you see my screen now.
We do.
Okay, so I will continue with hoisting and closures. And what is hoisting? This is a JavaScript mechanism where variable and function declarations are moved or hoisted to the top of their containing scope, either global or local, during the compilation phase before the code is executed. There is a temptation to think that all of the code you see in a JavaScript program is interpreted line by line from top to bottom in order as the program executes. And while this part is substantially true, there's one part of that assumption that can lead to incorrect thinking about your program. And consider this code. Can you share in the chat what do you expect to be printed in the console? Correct, Warren. In the console, we printed the variable. When you declare a variable using var, JavaScript does two things. The first thing is declaration. The declaration itself is hoisted, moved to the top of its scope. And the second is initialization. The value assignment happens in the original place in the code. Before the code is executed, JavaScript will move the var declaration to the top of the current scope. However, the variable will be initialized with the value undefined until the line where you actually assign it a value. Now let's see what is happening with the var hoisting. JavaScript hoists the var declaration to the top. Even though the console log is placed before the var a equals 10 line, and the variable a exists, but it's initialized with undefined until it gets the value of 10. And finally, when you console log, you get the right output. Under the hood, JavaScript sees this code like this. First, we are initializing the variable as undefined, and here on the second line, when we console log it, we get undefined. Then we are assigning a value, and at the end, we are console logging, and we are getting the right value. Variables declared using let and const are also hoisted, but with a big difference. They are not initialized with undefined like var. Instead, they are placed in something called the temporal dead zone from the start of the block until the variable is initialized. And in other words, until the code execution reaches the line where the let or const variable is declared, it cannot be accessed, and any attempt to use it will return in a reference error. Let's see this example with let. Here we are trying to console log the variable b, which is declared with let, and we are getting the reference error. And it's the similar case if we are using const. Again, when we console log the variable before we assign a value to it, we get the reference error. Why does this happen? Even though let and const declarations are hoisted, they remain uninitialized until their actual declaration is reached in the code. And this period between the start of the scope and the declaration is the temporal dead zone. Now let's see how functions are hoisted. And we will start with function declaration. Unlike variable hoisting, entire function declarations are hoisted to the top of their scope, including both the declaration and the definition, the function body. This allows you to call a function before you've declared it and in your code without causing an error. Now, let's see what is happening here. The entire say hello function, both its declaration and body, is hoisted to the top, so JavaScript knows about the function, even though it's defined after the call. And things work differently for function expressions. In a function expression, the function is assigned to a variable. The variable is hoisted, but since JavaScript treats function expressions like regular variable assignments, only the variable declaration is hoisted, not the function definition. And we have this example with the say goodbye function. The variable say goodbye is hoisted, but just like with var, it is initialized with undefined until the function expression is reached. So when you try to call say goodbye before the function expression, JavaScript throws a type error because say goodbye is undefined at that point. And arrow functions, like traditional function expressions, are not hoisted in the sense that you can't use them before they are defined in the code. They are treated as variable assignments, so only the variable declaration is hoisted, not the function itself. Arrow functions are assigned to variables, and the behavior of the variable depends on whether it's declared with var, let, or const. And we'll see a few examples now. The first example is with var. What is happening here? The var at declaration is hoisted and initialized as undefined. When you try to log at before its definition, it outputs undefined. And when you call at the function after the function is assigned, it works as expected. Under the hood, it looks like this. First declaration is hoisted. In the second one, when we try to console log the variable, it is undefined. And the actual initialization happens here on the third line. And finally, when we console log, we get the expected output. Another example with let. When you declare an arrow function with let or const, the variable is hoisted but is placed in the temporal dead zone until the line of initialization is reached. You cannot access it before it is defined, and any attempt to access this variable before it is defined will result in a reference error. And as you can see, when we console log the function after it is defined, we get the correct output. We have similar example with const. In this case, the variable subtract is hoisted, but it remains in the temporal dead zone until the line where the arrow function is assigned. Before that point, trying to access it results in a reference error. And under the hood, it looks like this for let and const. On the first line, variable is hoisted, but it remains uninitialized in the temporal dead zone, and we get the reference error. The actual initialization happens on the second line, and on the third line, we are getting the correct output. Summary of hoisting. First, function declarations are fully hoisted, meaning you can call the functions before its definition. Function expressions and arrow functions are treated like variables, meaning only the variable declaration is hoisted, not the function itself. And this leads to var are hoisted with undefined, and they cannot be called before initialization. This word is so hard for me to pronounce it, sorry. And let and const are hoisted into the temporal dead zone, results in a reference error when accessed before the declaration. Now let's talk about closures. What is closure? Closure is a feature in JavaScript where an inner function has access to the outer, enclosing functions variables even after the outer function has finished executing. Key characteristics of closures are lexical scoping. Mariya talked already about that. Functions are executed using the scope chain established at their creation, and private variables allows creation of private variables that cannot be accessed from outside the function. Closures are fundamental for many JavaScript patterns and are essential for writing efficient and maintainable code. Now let's see how closures work. We have lexical environment. Lexical scope is determined at the time of writing the code, not at runtime. And scope chain. Each function has access to its own scope and the scope of its parent functions. Creation of a closure. When a function is defined inside another function, the inner function retains access to the outer function's variables. And even after outer function execution, the closure preserves the outer function scope, allowing the inner function to access those variables later. And memory management. JavaScript's garbage collector ensures that variables within a closure are not collected as long as they are accessible by the inner function. And basic closure example. What is happening here? We have the inner function, which retains access to the outer variable after the outer function has been executed. And you can see here, after the function, we are declaring a variable myClosure, which gets the value of the outer function, and we get the output of the outer variable. And another example with the counter. Each call to counter increments and returns the private count variable, and every time we console log, we get the result incremented by 1, which is happening here in the inner function. Now let's see some advantages and benefits of closures. And the first is enhanced modularity. Break down complex problems into smaller, manageable functions. Data privacy. Protect variables from unintended external access and modification. Reusability. Create generic functions that can be customized with different environments. And state persistence. Maintain state across multiple functions, invocations without global variables. And some best practices for closure. Minimize scope. Keep closures as small and focused as possible to reduce complexity. Avoid unnecessary closures. Only use closures when they provide clear benefits. Manage reference carefully. Ensure that closures do not hold onto large objects longer than necessary. Use modern syntax. Leverage ES6 features like arrow functions for cleaner closure implementation. And clear naming conventions. Use descriptive names to make the scope and purpose of variables clear. And that's from my side. Thank you so much.
Thank you so much, Violina. Amazing session and slides.
Thank you. I hope it was useful for all of you.